All right, so let's talk about graphs and tables. They kind of go hand in hand. I'm going to start with this list of ordered pairs, and I claim this is an invertible function. Well, and I also I wanted to go ahead and I want to create a piecewise linear function out of these x values. So I only defined it for these 5 values, but I want to create a function that's also piecewise linear, just because a lot of the graphs in the textbook look like this as well. So let's go ahead and do that. So maybe I'll count by fives here, and it doesn't have to be perfect, but I should try anyway. And I'm going to have the x's go all the way up to 15 as well. So I want to talk about this function, this sort of random function, just piecewise. I just want to draw some diagonal lines that connect all these things. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, that's pretty good. And I'm going to use black for this one. This one, maybe I'll use green when I do the inverse function. So just the function itself, I have a point 0, 4. I have a point x is 2. Maybe I'll make this hash mark not quite so large. X is 2, we get y is equal to 5. And x is 4, y is equal to 8. Six. So it's a little steeper. That one's shallower. Yeah. So finally, when x is 8, it goes all the way up to 13. So it gets significantly steeper at the very end here. Okay, so the idea is that I have this function that I originally defined just using a table, and let's just say that it's also piecewise linear in between the sample points, just to extend the definition to give us a little bit more to work with. So if we did have a function that was linear in between the sample points, and it was like strictly increasing, well, first of all, here's the horizontal line test. You can see that for every output, there's you either never get that output or you get that output exactly once. So you always know which x gives you which y. So inverting this is no problem. It's just a whole bunch of diagonal lines and little line segments, but yeah. So the function that does the opposite of this, it just takes that output and gives you the original input back. So 0, 4 becomes 4, 0. The function that goes backwards, it's like if this were x and x squared, then the square root function would be going backward. But it's just all the same ordered pairs in the opposite order there. So in green, I've got when this point right here, 0, 4, corresponds exactly to the inverse function's point 4, 0. And what I'm going to do is I'm actually going to draw a little. These two are actually connected to each other, kind of, because the input and the output are just the roles are completely reversed. And if I draw a diagonal line, it's actually like perfectly diagonal. It's sloping like -1, which is kind of interesting. Let's see what happens if we do it again. So 5. So this 2, 5 in the original function, the inverse function has 5, 2. And that's really nice. This next one, if I have 4, 8 in the original function that's up here, then now I have 8, 4, 6, 7, 8, 4, 8, 4, and then 4, 8. Or 4, 8 becomes the green point 8, 4. 6, 9 becomes 9, 6. So here's 9, and then we go up to 6. So it's really nice here. It takes a long time. It takes, well, not that long, but it sort of takes us a bit of work to get here. So we have 8, 13 in the original function as a black point. Then in green we have 13, 8. Which is over here. And in general, we have, you have a point AB. The inverse function has the point BA. So like if 2 squared is 4, then the square root of 4 is 2. So it's and kind of the end result of this is that there's this it's like its axis of symmetry or axis of reflection or whatever you want to call it. It's a line of symmetry not for the function itself, but between the function f and f inverse. So it's more like an axis of reflection. If you have this one-to-one function f and you reflect it over the line y is equal to x, then you get a graph of the inverse function. It's easier to see it with 2 different colors because, well, the function itself, there's no reason why the function wouldn't be allowed to sort of be really steep and then maybe shallower. And as long as it's one-to-one, it's possible that the line could cross over the line y equals x, and then the reflection would interweave and zigzag. And those are a little bit complicated. But if you take it slow, and you do it very, very slowly, well, you start with drawing the line y is equal to x. Then one at a time, you find points on the function f. You find your x and your y, and then you very slowly you do the mirror image of each one by just reversing the roles of x and y. You do that slowly, and then you connect the dots, or maybe they're curves. If this is a curve, then you do the opposite curve. And in particular, the textbook problems where they have you look at graphs and they have you say which one's the inverse, or in the MyLab tests, same idea. If you do this carefully enough, it shouldn't take too long to find contradictions or just stuff not lining up right. You just do it nice and slow. You draw the axis of reflection, then reverse some of the x and y coordinates of some of those ordered pairs, and then it either lines up like it's supposed to, or something's going to be off by a lot. It takes a little getting used to, but that's kind of that. We just saw it. We did it from scratch, just straight from the definition, and we saw it firsthand. And it always works like that. It's just kind of and it's just what it looks like when you do it. So pretty cool stuff. All right, so did I really have anything more to say about this? I'm not really sure that I did. Let me double check the homework assignment. I think that was basically it as far as that stuff goes. Yeah, take a look at the textbook. Yeah, I think the first video covered lots and lots of ground. So I think we can sort of keep going here. So maybe we do one more example. Let's just find yeah, so if I want to split it in two videos, maybe I should give you one more example, make this one a little bit longer, just in case it wasn't clear the first time. So in black, I'm going to do y equals f of x. Let's do this nice sort of yeah, so let's just say this is unit scale. So this is 1, 2, 3, 4, 1, 2, 3, 4. Just keep it simple. But I should actually define these things. So all right, so this one's a little bit weird. It starts out looking like the cube root, but it does some weird stuff over here. I think it's a little bit unusual, but it still defines a function because, well, horizontal line, it's still invertible. Looks like for every output, there's only one input that gets me there with the function. And well, what do I have to do? Well, probably the very first thing I want to do is I'll make a lot fewer mistakes if I have this axis of symmetry that really is going to guide me when I take this ordered pair. And if I don't want to make, if I make a sign error or I get my x or a y in the wrong place, it should jump out at kind of immediately if it doesn't line up with the axis of symmetry like it's supposed to. I think I accidentally made this a little bit too small here. Let me expand that, but okay. So let's just start from, we can start anywhere. We just have to make sure we do everything. So let's just start over here. We have -4, 0, which belongs to the original function. So the inverse function has 0, -4. And reflected, it looks like if I go along the axis of symmetry, equally far both directions. That's kind of what it looks like. So then I have 0, 1, which becomes this 1, 0. Then this 1, 2 becomes 2, 1. This 2, 3 becomes a 3, 2. And this 4, 4 becomes, well, both of them cross the axis of symmetry at the same time, and it's kind of, it's either, as you go along the curve, either you're straight or diagonal, or either bending together. You're either, in this case, they're both bent curling toward the axis of symmetry. It kind of looks like you're doing pottery. Like with clay or something, is kind of what it looks like. And then so it curls inward and then it curls away. It doesn't have to be super duper perfect, but definitely with the MyLab tests and the multiple choice, one of them is going to be correct, and the other two, something about them is going to be really off and kind of fishy. And just starting with the axis of symmetry is the very first thing that you do. Is going to really set the tone for it, and then plugging in a few extra points here and there will really help sort of nail it down and really make sure you get the right thing. So here is y equals f inverse of x. So if f of 2 is 3, then f inverse of 3 gets you back to 2 again. So so that's it. We'll just stop this one here. I think 2 short videos instead of a long one might be better. So we'll do the algebraic thing next time. I think there are only 1 or 2 questions on the MyLab test about that, but should be pretty doable. So we'll do that.